Assalamu alaikum. Here is the frame for our rover. It consists of two parts, a top part and a bottom part that will be assembled together to give us the final model that we will use with all the components for the project.
Assalamu alaikum. First of all, let's show that potentiometers work. I'm gonna change motor A to 0, and then I'm gonna go change motor A to 5, and back to 0. Same for motor B. Gonna change it to 5. Then I'm gonna change it to 0. Okay, now if you see, if you look at this motor, it's not working now, and if I change potentiometer A, it changes according to voltage. Now I'll slow it down a bit, and now I'll make it stop. This is the motors at maximum speed. Now I'm gonna get closer. They won't start slowing down until it reaches a limit, and then it starts slowing down slowly until they come to a stop, a complete stop. And now if I go further from the wall, they start moving faster and faster until they reach full speed. That's it.
Assalamu alaikum. This is our project for MECH 532, Design of Mechatronics Systems. This is a rover that we built. So if you come closer, and if I remove the top part here, you'll notice that there are many components that comprise the rover. So we have an Arduino Uno board here with various connections, and as well as an edge bridge. So we also have a mini board here instead of the usual bigger board. So the connections between them, they're convoluted, but in general, the edge bridge, there's 2 enable pins for the PWM connections to control the speed of the wheels. And the Arduino Uno is used for digital connections, connecting between the board and the ground and the power supply. So you'll notice here that the brackets here are used to maintain the elevation of the wheels themselves, so that we can adjust the height, and so that we can also accommodate for the height of the third wheel, which is a 360 wheel. It can rotate in 360 degrees. We also have 2 sensors. We have a right sensor and a front sensor. The front sensor acts as an obstacle detector. If there is any object in front of it by 1 meter, it will stop. And the right sensor, it acts as a distance maintainer. So if there is a distance of 1 meter, it will maintain it, and if it's higher, it will turn right to adjust the distance, and if it's too close to a wall, less than a 1 meter distance, it will adjust and turn left. So we can, and this is enabled by the PWM within the edge bridge to control the speed of the wheels. Now my other colleague will continue.
For our power supply, we use 2 power supplies. One containing 2 batteries, each of 3.7 volts, to power the motors and the edge bridge, while the other power supply is just a 9-volt battery that we use to connect to the Arduino directly, to power the Arduino and the sensors.